Now you can hear me? Good? Huh? My name is Sara Lidén. I work for Onisha AB, and we are representative of EHP Technica here in Sweden. First, some words about EHP Technica. It's a Finnish company based in Oulu, in the north part of Finland, so quite just east from Skellefteå. They have worked with in the field of online environmental monitoring for over 15 years, and are integrator of sensors for monitoring solutions for the heavy industry in field conditions as well. They are both selling, renting, and providing solutions for water, soil, and weather monitoring, where the water monitoring is their expertise. Just to say a few words then also about what is online monitoring. This is a few different solutions. You have a monitoring well. This is during the installation. This is also a monitoring well and a weather station. Out in the exhibition hall, we have a monitoring buoy. They are working by using sensors in the water, so you can measure in surface water, in groundwater, then in soil, and of course the weather as well. In these monitoring stations, you have both the sensors. In this case, the sensors are located here. Here is the flow measurement. They are powered by solar energy and batteries. That's why they work in also in field conditions. You don't have to have the power grid connected directly to the monitoring station. They also work during winter conditions. In northern Finland, they have this monitoring solution, and it is tested that down to minus 40 degrees, the monitoring station is working. What happens then? Well, the data logger and such freezes temporarily and then starts to work again when it becomes warmer. I will, in this presentation, focus on the environmental monitoring concept called EnmonCon that EHP has developed. So I will show you a short movie of this environmental concept. So that you will get the idea of how it's working. So this concept is built on many different parts. We usually show it as a puzzle of different parts. You start with the online monitoring stations. Both you can have them as buoys, in pipes, or in rivers or ditches. The monitoring stations can monitor different water quality parameters, up to 60 water quality parameters, and also then flow and level. For the different parameters, we can measure normal parameters such as pH, temperature, redox, conductivity, down to more complicated parameters such as oil content in water, where we measure PAH components in the water. We can also measure heavy metal in water, where we have our specialist here for further questions on the metal concern. And also organic content such as COD, BOD, TOC, resulting in then 60 different parameters. These monitoring stations then monitor and sense the measured data in real time from 1 minute's interval to a data system, which we call EHP data service, where you have the data stored, and by also monitoring and sending the data in real time, you get the ability of having an early warning system. For example, if you have an oil leakage and you measure in that ditch, you will get an alarm to your telephone or email saying that you have elevated levels of oil, and therefore you can prevent the oil leakage from becoming large. This works for all of the parameters. You just set the limit to where you want it to be set, and then you get the alarm. This data system also makes it easier for the reporting part, where big companies have a lot of reporting to be done and spends several hours on working on Excel sheets. By using EHP data service, you have these normal types of reporting ready to be done. You set the time interval, which parameters and such, and just print it out and you get the report. Some of our clients has wanted to link their data to the authority, which then also is an option. However, not everyone wants to do this. And for the whole concept, we don't think only that the online monitoring stations should be part of the collection of the environmental data to the system. Should also have the manual samplings and laboratory analysis to be a part of this data system, so that all of the environmental data is located in one place. For the both the maintenance, of course, the online monitoring station needs some maintenance, but also for the manual measurements. For example, if you go out with a portable pH sensor, you can directly put it in the system, so that everything is in as real time as possible in the data system. Part of the data system is also the data management part, where you can have this map-based part of visually looking at the plant. This is, for example, a landfill in Finland, that you have all of these different parts of where you monitor. This is both manual measurements and monitoring stations. And the idea here is that you can start your morning by looking at your map of your plant and see if everything is green on all of these dots. That means that the environment that you monitor is good. If the case is as here, where most of it is red, well, you should probably do a check of what is going on, because of the environmental state is not that good. And this is based on then the limits that you set for each parameter for each location. Going on to the benefits of this Evironmental concept, it is designed for the industry. That is why most of this is then also benefits for the industry. It represents best available technology and also answers to the upcoming ISO standard 14001 of the tightening of the risk management, where there are parts of this new ISO standard is that you have to have better risk management and prevent and also minimize the risk even more than the prior ISO standard. You get the real-time status of the environment, meaning you always know what is happening. When you monitor continuously from a few, 4 times every hour or even more, you will always know what is happening. Early warning system. You can prevent catastrophes and save your reputation, meaning you can then, if you get an alarm of the example of the oil leakage, you can minimize the actual oil leakage. Faster environmental reporting whenever needed. Cost efficiency. You can reduce the total cost of environmental monitoring. I will also come back to this in next slide. Process optimization due to better control of emissions. We have a few different examples of process optimization, but one example is if you measure the content of the water for a specific parameter that goes into purification plant, and you have to add different types of chemicals to this water to be able to clean it. If you know how much is going in or going out, then you can also adjust the level of the chemical for the cleaning process. This also saves money in the end. And then also all of these services are from one desk, meaning that it's easy to purchase and manage. Due to EHP can do the design of the whole monitoring project. They build the stations, they do the installations, and also service and maintenance of the stations. Coming to the cost efficiency, this is from a study done in a peat production plant, where you can see the blue is then the manual sampling, taking, and laboratory analysis from 0 to then 20 years. The red is Evironmental, how much savings then if you take one sample per 6 weeks. And then also the heavier monitoring situation. So you can see, of course, the investments costs might be higher, but in the long run, you will save money by not having personnel and lab analysis to be done very often, as this costs money both to send people out to take the measurements, but also the laboratory costs are included in this calculation. And not only for the monitoring itself, but also for the availability of having these early warning systems. If there is a big leakage of something that is not supposed to be in the environment outside of the industry or the plant, then you can actually save money by preventing the actual leakage instead of having to clean it afterwards. Another big part of why continuous online measurements are good is that if you only take manual samplings and laboratory analysis, you will only know the state of the environment in that specific time. Meaning the blue line is the online environmental monitoring, and these dots are then the manual sampling. If you monitor continuously, you will get these peaks. If you do not monitor continuously, you might be lucky to get the peak, but you might also miss it. Meaning you don't know what is happening in between. And lastly, I just want to say a few words about the measurement uncertainty, because some people do not think that using sensors or technology for this type of monitoring is good and trustworthy. EHP wanted to have a look at this, so in collaboration with MIKES, the Center of Meteorology in Finland, they did this study on a peat production site where they compared pH, turbidity, suspended solids, and COD by comparing manual sampling and laboratory analysis with online measurements. This is then the expanded uncertainty and the different parameters. Green for the manual sampling and laboratory analysis, and blue for the online measurement. For pH, it was actually a tiny bit better to do it with manual sampling and laboratory analysis, giving 0.24 pH units versus 0.30 with the online. But for the other parameters such as turbidity and COD, the difference is quite similar, where the online measurements actually have lower expanded uncertainty compared to the manual sampling and laboratory analysis. But what surprised us was when it comes to suspended solids. The expanded uncertainty using manual sampling and laboratory analysis was 84%, meaning that it will be up here somewhere, if this chart would be long enough. What we take from this is that should people really want to pay for the sampling and the analysis when the expanded uncertainty is as large as this? What do you really get for your money? And according to this study from MIKES, online measurement is also quite certain. And that was all from me. We are in booth 236, just outside here, so please do come and visit us there. And if we have time for a few questions, I can try to answer them. Yeah? Well, when it comes to dam safety, you cannot predict that it will happen in whenever it will happen. But what you can do is when you monitor the level, you can see when it starts to rise. But do come and talk to the CEO of the company. He's in the booth. He can tell you more about it. Because we have some cases of dam safety as well. But thank you for coming.